Hello, everyone. Today, I would like to discuss with you guys how to write down electron configurations for elements. If you remember from our last lesson, we were talking about the different quantum numbers that are associated with an element. Today, I want to talk about how we write out the configuration of the electrons for that element. So let's take a look at our lesson for today. So writing electron configurations. So an electron configuration does a few things for us. Okay, it explains where electrons are located within an atom. If you remember from our last lesson, we were talking about the different atomic models that have been presented over the years. And we remember that the last model that we know of is from Heisenberg and Schrodinger, where they determined that an element doesn't necessarily have a specific place all the time, but that it can be found using probability. And we can determine where that that electron would be located using that probability. And the electron configuration gives us three pieces of information. So we talked about the four different quantum numbers. One of the pieces of information that this electron configuration will give us for these electrons is the principal quantum number. And if you remember, the principal quantum number is the energy level of that electron. Okay, how much energy does that have? The second piece of information that we get from the electron configuration is the orbital quantum number. And that orbital quantum number gives us some shape to that atom. That sublevel S, P, D, and F tells us, okay, in this particular area, we should be able to find an electron. Okay, and then the last piece of information that the electron configuration gives us is the number of electrons. Okay, and we'll get into this and you'll find out a little bit more about how we actually determine all of these quantum numbers as we go. So taking a look at hydrogen here, our simplest atom, okay, has one electron. And the principal quantum number, if I were to write the electron configuration, it would be simply 1s1. So our principal quantum number is 1, meaning it's in the first energy level. The orbital quantum number is s, okay, that's that sublevel shape. And the total number of electrons, in this case, the only electron that is in this particular orbital is 1. Okay, 1 electron in hydrogen. So as we're writing this out, we first want to determine what that element's address is. So we kind of think of the address as that endpoint, where that last outermost electron is going to be located. So we'll call that the address, but we need to figure out how do we get there. Okay, again, that's that location of the last electron for that element. But to get to that address, we need to fill in all the lower levels for all the other electrons that are in that atom. So we fill in those levels below, giving us directions, if you will, to that address. So we always start with the lowest orbital, okay, the lowest energy, which is going to be 1s, and then we fill up from there. So let's take a look at what identifies those quantum levels. Okay, so our quantum levels can be numbers 1 through 7. Okay, the sublevel orbitals, okay, that shape, there's 4 main shapes that we'll look at, S, P, D, and F. And then we need to know how many electrons are in the orbital for that particular element. And here's how we do that. So we have 7 energy levels, which coincides with 7 periods on the periodic table. Okay, and if we take a look at this particular element here, where the star is located, happens to be tellurium. It is in the 5th row, so it is the 5th energy level. It is also located in P block. Okay, so P block. So we know the address is going to be a p orbital. In fact, this lets us know it's going to be 5p. Now there's one last piece of information that we need to know. Okay, how many electrons are going to be in that p orbital? So if we take a look at P block here, okay, we could take a look. 1, 2, 3, 4. It's in the fourth group here in P block, meaning that P orbital, that 5p orbital, is going to have 4 electrons in it. So the address for tellurium is going to be 5p4. 5 for the energy level, that principal quantum number. P is that orbital quantum number. It's located in P block, and it has 4 electrons in it. So the address is 5p4. How do we get there? Okay, that's not the entire electron configuration for tellurium. So if we wanted to get there, we need to follow the address. And you don't have to memorize all the different orbitals, but you should be able to read the periodic table in order to determine the directions to get to that atom. So you follow through each row. Okay, so 1s, and you fill it with electrons. It can hold 2 electrons. 2s2, 2p6, and then our next row, 3s2, 3p6, and so on. Okay, so our directions, 1s, 2s, 2p, 3s, 3p, 4s, and so on. Okay, and we'll get to some of these other orbital shapes here as we go. Okay, so let's take a look at carbon. Carbon is located right here. Which block is that? Yeah, that's P block, right? What energy level? What is our principal quantum number in there? Okay, that's going to be our period. Okay, so let's take a look here. Here's carbon. Take a look at it here with the electron configurations written on it. So if we follow our way, we fill up 1s orbital with 2 electrons. We'll fill up the 2s orbital with 2 electrons, and then we reach the 2p orbital, and it's in the second group there, and so 2 electrons in the 2p orbital. So that gives us our address and our directions, address being 2p2, and then we fill out all of the lower energy levels to get to 2p. So address is 2p2, our directions to get there, 1s2, 2s2, 2p2. Now, one other thing I want to mention here is if I wanted to add up all of the electrons, okay, all these electrons, 2 plus 2 plus 2 is 6, okay? Carbon has 6 electrons, okay? So we should be able to add those up as a way to double check to make sure that our electron configuration is correct. So let's take a look at sulfur. Let's take a look at another one here. Sulfur, also located in P block, okay, right here. What energy level is that located in? Right. Okay, so it's going to be the 3rd energy level, and it's in P block and the 4th group. Okay, 1, 2, 3, 4. If you notice, all of these have 4 electrons in the p orbital. Okay, so the address for this is 3p4 for sulfur. And then our directions to get there, again, we just read across the periodic table, okay, filling up each of the orbitals to get to 3p4. So sulfur then, the address is 3p4, our directions to get there, 1s2, 2s2, 2p6, 3s2, and 3p4. Again, we can add up all of those electrons, okay, 16 electrons, so sulfur should have 16 electrons, and it does. Okay, and so this is how we would write out that entire electron configuration for sulfur. All right, let's take a look at a few of these. Hydrogen, we already kind of went over, right? Hydrogen has 1 electron. So where is it located? 1s1, well, that already fills up all of our electrons. Okay, let's keep going. Helium, how many electrons in helium? Right, 2 electrons. Okay, so the address for helium will be what? Still in the 1st energy level, so it's 1, and also an s block. Okay, one s2, a total of 2 electrons. Remember, each of these s orbitals can hold a maximum of 2 electrons, if you remember from our last lesson. Okay, what's the maximum number of electrons that the p orbital can hold? Okay, the p orbital can hold 6 electrons. So let's take a look at lithium. Lithium has 3 electrons. So the electron configuration for lithium, 1s2, 2s1. Okay, beryllium, 4 electrons, 1s2, 2s2. Okay, now we start moving over to another sublevel block. When we look at boron, okay, boron, 5 electrons. So again, it still has all those previous electrons, those previous 4 electrons that we looked at already that have lower energy than that 5th electron. So we still have 1s2, 2s2, 2p1. Okay, carbon we already looked at, 6 electrons. So our address for carbon should be 2p2. And we fill in the previous electron configuration orbital groups for that. Okay, nitrogen has 7 electrons, 1s2, 2s2, 2p3. Okay, oxygen has 8 electrons. And so we add 1 more electron to that 2p orbital to get 1s2, 2s2, 2p4. And if you notice here for all of these, okay, they're circled up here for boron, has 5 electrons. Should add up to that total for every one of these, okay, whenever you're writing out these electron configurations. Okay, so fluorine has 9 electrons, 1s2, 2s2, 2p5, and neon. Okay, I want you to pause this, write out the electron configuration for neon, and then resume, and we'll take a look here. All right, now that you've written out the electron configuration for neon, it has 10 electrons. So hopefully you wrote out 1s2, 2s2, 2p6. Okay, I hope that this is helpful for you all to determine the electron configurations for these elements as we move forward. Our next lesson will be as we go further down the periodic table and look at some of the other sublevels, the D and F sublevels, and how to write out the electron configurations with those. So feel free to message me if you have any questions on this, and I'll see you in the next lesson. Thanks.